Hello, everyone. Welcome to the Centaurus session today. As you know, cloud computing has come a long way. Some of the enabling technologies and concepts actually started out in the 60s with the emergence of utility and grid computing. Then we went through the pre-cloud phase from 1999 to 2006, when internet was the mechanism to provide an application as a service. Then in 2007, that is when we officially entered the cloud era. Enterprises started monetizing infrastructure as a service, platform as a service, and software as a service, etc. Over time, cloud has become the de facto platform for innovation and service consumption. The last 5+ years, we have also experienced the explosive growth in 5G, edge computing, AI, machine learning, AR, VR, IoT, IoE, and now we're talking about Metaverse, which has inspired the development of many exciting digital services that we're using today and in the future. Cloud infrastructure, no doubt, has always been the backbone of the delivery pipeline of all these digital services. In today's session, we'll discuss how cloud should evolve to meet the needs of 5G, edge, AI, and the Metaverse. As we are moving into a more and more intelligent and connected world enabled by 5G, edge, AI, and the Metaverse, we can expect that the cloud will need to have massive compute, network, storage, edge, and security capabilities. We believe that the open source cloud infrastructure we have today will no longer suffice. The new cloud architecture will need to support high scalability. Here we're talking about hundreds of thousands of nodes per region or a cluster with high performance and low latency. It needs to be distributed so it connects reliably with various edge nodes that support IoT or IoE. It needs to support AI and machine learning platforms where high performance compute is needed for AI training on the cloud and AI inferencing on the edge. Last but not least, serverless cloud is a relatively new concept, but has been gaining traction. Sometimes it is referred to as function as a service. It is still pay-as-you-go service model, but the cloud infrastructure scales invisibly as cloud service requires us. A year and a half ago, we launched the Centaurus Umbrella project under Linux Foundation. The project is designed to support large-scale distributed cloud. In the next 20 minutes, Deepak, who is the TSC chair of the Centaurus project, will give an overview of the Centaurus project, followed by Prashant and Rupal from Click to Cloud, who will show you a Centaurus use case, the future gaming on the Metaverse. I hope you'll find today's information useful, and we would love to have you join the journey of Centaurus with us. Thank you.
Hi, my name is Deepak Page, and I'm a cloud technology strategist at FutureWay Cloud Lab, based out of Santa Clara, and I'll be presenting an overview of Centaurus project. It's a large-scale open source cloud infrastructure project. Yeah, so the project Centaurus is an open source Linux Foundation project targeted towards building unified and highly scalable public or private distributed cloud infrastructure. So we, FutureWay Cloud Lab, built out this project and donated it to Linux Foundation. It's an official Linux Foundation project about a year and a half ago. And so this is, Centaurus is a unified resource management and orchestration layer across multiple types of workloads, such as serverless, virtual machines, containers, as a single pane of glass. So it's essentially a unified cloud infrastructure for managing different types of workloads. And it aims to meet the challenges for new types of workloads, such as AI and 5G or Metaverse application landscape. And these applications exhibit very unique characteristics, such as low latency, mobility, location awareness, privacy, and security. So the cloud infrastructure, enabling cloud infrastructure needs to be able to address all these issues. And as I mentioned, this is a cloud hyperscaler grade open source project. Available in open source, so any enterprise IT organization can take this software and build out a hyperscaler grade cloud environment. So the Centaurus is an umbrella project across 4 projects underneath it. Arktos Compute, Mizar Networking, Fornax AI, and Fornax Edge Computing, and Alnair AI project. Just similar to what OpenStack is. OpenStack is the umbrella project for Nova Compute, the Neutron networking, and and the storage. It's just a similar structure. So Arktos is an open source project designed for large scale cloud infrastructure. It evolved from Kubernetes code base and features a lot of similar API interface, such as the pods, replica sets, deployment sets, and all that. So, in order for us to be able to enable these 3 capabilities as part of our project, Centaurus project, and these 3 capabilities are unified cloud infrastructure resource support, high throughput and low latency, multi-tenancy support. So we had to do major overhaul and enhancements to the upstream Kubernetes code base in order to incorporate the core design changes for enabling these features. And this is essentially the overall architecture overview of what Arktos Compute looks like. As you can see that we have partitioned the control plane and the data plane in order for us to be able to enable the high, the scalability, the hyperscaler grade scalability. So we had to do major overhaul in the Kubernetes system to enable new constructs such as tenant partitions, resource managers as part of the overarching Centaurus architecture. And it's a public cloud level scalability. It can accommodate up to 100K, 100,000 nodes. Typically in open source, OpenStack, or Kubernetes, they don't really go beyond actually 15K nodes in a cluster. So all control plane components are scale out and highly available. Tenant workloads are partitioned. So multi-tenancy, we built it from ground up, actually. So we had to do major overhaul and surgery in order for us to enable the hard multi-tenancy as part of our Arktos compute environment. So essentially, constructs such as tenant ID flows through the entire Kubernetes code base. The namespace aware API objects or system level non-space API objects. By doing that, by having this tenant ID flow through the entire system, we are able to build out hard multi-tenancy as part of our Arktos compute component. So Arktos unified runtime orchestration, I already talked about it. So essentially unified support for different types of workloads, such as VMs, containers, serverless, and tomorrow it could be WASM, WASI, WebAssembly, or unikernels, or maybe some other new runtimes. Mizar Networking is a network virtualization we built out as part of our next generation Centaurus cloud platform. And this large-scale cloud platforms like Centaurus, they need to scale up in order to support enterprises' entire global footprint. So we wanted to be able to support a very rapid provisioning of cloud resources. Instead of assuming that the workloads are provisioned in a daily or an hourly manner, we know that in a cloud environment, workloads are deployed and are provisioned in a fraction of a second. They're very dynamic environment. Serverless serverless workloads come and go. Containerized workloads come and go. So none of the contemporary open source networking solution measure up to our needs. So we ended up building this network virtualization layer as part of a Centaurus project. So there are a lot of problems with the current state-of-the-art network virtualization technology, such as OVS, Open vSwitch. They are flow-based solutions. They are not scalable. And then the high utilization, as the number of ports, as number of nodes increase, the overall time to provision increases as well. So it doesn't overall, the system doesn't scale. and it doesn't meet our requirements. So in order to address the scalability challenges, so we ended up building from ground up the network virtualization layer called Mizar. Mizar networking layer leverages XDP. XDP is an express data path provided by Linux kernel, and essentially by using XDP as the data path technology, we are able to process packets at the device driver, NIC device driver level itself. So that makes the overall performance much better. And this is kind of a high-level pictorial of what architecture is. As you can see that, so essentially the whole the network virtualization functionality is embedded into XDP programs. So one program called XDP Transit is connected to the XDP program. It's connected to the main interface, and we call it a transit XDP. And then we have another XDP program on the VF pair that connects to the workload, such as container or workload, and we call it a transit agent XDP. So these are the two XDP programs, and they use a common eBPF maps that are programmable from the user space by transit daemon. So any user space program can make a RPC call to the and then program and populate constructs such as regular maps, hash tables inside the kernel, and that's how you configure your network virtualization environment. And these eBPF, the XDP programs, leverage that configuration and then are able to perform the network virtualization functionality in the system. So just kind of a high-level summary, kind of repeating it. So the current programming model doesn't work for us, so we ended up kind of building it. And our XDP, we are in the process of offloading that XDP network virtualization layer to SmartNIC to make it even more efficient and highly performant. So that's next sub-project is Fornax Edge Computing. Fornax Edge Computing is an open source edge computing framework for managing compute resource on the edge environment. And it's designed to solve the key edge computing challenges due to limited computing resources, heterogeneous resource types, layer topology, unreliable networking, and long latency. So essentially, it can the whole topology could be hierarchical based. You can have a central cloud, you have regional cloud, and you have a sub-regional, and then at the leaf node you may have edge node that doing processing. Also provides a high performance virtualized networking for the workload communicating within and between edge clusters. So these are the various features. Hierarchical topology, I already talked about that. Flexible flavors, different type of orchestrators, compute environments such as Arktos, Kubernetes, K3s. And this is a pictorial of hierarchical topology, how it looks like. So Alnair AI, so the focus of the Alnair project is more at the system, enabling system level. So as opposed to building algorithms. So essentially, we are building a system for us to be able to do AI training and AI inference in a much more efficient manner. So that's the focus of Alnair, is that more at system level enabler for the AI functionality. So these are the key features: elastic training, dynamic GPU allocation, GPU utilization profiling. So all of these features, parallelism at data level, model level, pipeline level. So these are the key features. And then now, this is what all I talked about till now is all current Centaurus, how it looks like. So now transitioning to Centaurus 2.0, the key thing is we building out a regionless computing platform. So the computing-less, the region-less, the current, even the hyperscalers, the cloud computing model is at the region level. So you specify where do you want to deploy your applications, in which region specifically. But by doing that, by limiting yourself to a region, it creates a resource imbalance across multiple regions. Some of the regions could be overloaded, and some regions are sitting empty. So in order to handle that challenge, we are building out a regionless cloud, essentially that will provide a uniform interface to the user. It doesn't really matter what region their workload gets deployed in, and that way we can efficiently manage the underlying resources. So as part of the project, we have a brand new resource manager, new distributed scheduler, and then we have a key value store that needs to manage the cluster information across all regions. And then we have a new container container virtualization we call Project Quark, which is built from ground up. It's very lightweight and much more performant than the existing state-of-the-art the container environment. It is best built using Rust programming language. So these are the projects we are working on as part of Centaurus 2.0. But one of the things, there are a few things I wanted to highlight that actually you see. So whatever shape or form these application landscape is, Metaverse or AI or 5G applications, but they're going to demand, they're very unique. They're going to demand massive upgrade to our current underlying infrastructure plumbing. Essentially current compute and network is going to be massively revamped. So especially from a compute perspective, a lot of heterogeneous hardware technology landscape will serve as enabler for the next generation compute environment. And the fact that though you cannot just throw CPU cores at your problem, basically. This is how the traditional cloud computing was. Just add more, the commodity servers. But we have all realized that even hyperscalers have realized that a lot of processing makes sense to do some of the processing we are currently doing at the CPU level to the specialized hardware, at the SmartNIC level, at the GPU level. So that's the key design strategy going forward, hardware, software co-design actually. And these accelerators, they have a different ISA abstraction, the instruction set architecture abstraction. So these are the challenges we kind of factoring it in as part of our infrastructure. And resource disaggregation, memory disaggregated from the host itself, the storage and all of these things are disaggregated. So you can manage it, your memory, your storage much more efficiently, And the network technology needs to be able to enable upwards of 400 gigabits or terabytes, and SmartNICs are going to play a big role. And so essentially, all of these immersive metaverse-like applications, they're going to demand disruptive compute networking and storage technology landscape, actually. And these are all things we are kind of factoring in as part of our cloud platform Centaurus going forward. And so we as I mentioned, Linux, this is the Centaurus Linux Foundation project, and we have a TSC. We do monthly meetings. So we have 7 TSC members, and we have an advisory board. We have subcommittee of marketing and housing, and these are the links for the repo, and then the meetings. We publish meetings and the recordings, and we're very happy to have the community get involved and then address all the challenges which I enumerated in my presentation. This is all I want to cover. Thank you very much.
Hi everyone. Good afternoon. This is Prashant Mishra. I am a TSC member in Centaurus and founder of Click to Cloud INC. Today I'm going to talk about Metaverse and gaming industry in context of Centaurus. Looking at different industries, Metaverse has been so important experience for the end users, and we're going to talk about how technology is solving those problems for gaming industry. Even though we see a lot of value of such things in different industries like healthcare, manufacturing, and other areas, but today my focus of this talk will be on the gaming industry. Briefly, I want to talk about the gaming industry has been seeing a tremendous growth and an initial pioneer in setting up the tone for the Metaverse technology, because that's where we are bringing the virtual reality and augmented reality along with the human experiences together. And one of the reasons, like a lot of people are thinking, is about the compute power, the networking, the identity, the security theft, and other things. While we are addressing all those things, we are living in the world of technology where data is like a tremendous step towards learning and the growth. We are all looking at the technologies like artificial intelligence, lineage graph, knowledge graph, where constant learning will help people to explore the world which has not been uncovered in the past and bring a new experience. Let's talk about the life of a gamer in the metaverse. And we try to simplify this, and we will convert it into more into the technology aspect, when you can connect the experience of the metaverse gamer and the Centaurus platform in one synergy. Any typical gamer, they starts with their day with starting and logging into the PC, connect with the VR headset. So VR headsets bring a sort of like a connectivity with a virtual world where the person or avatar can think that they belong to that space. They start connecting with other people around the globe, where they are feeling that they are part of that virtual space, which can be a connection, relationship, or a friends in that area. They choose a different type of game. That's where the start of the gaming or the gameplay happens. They interact with the other players. But behind the scene, I would like to emphasize on the fact that all these experiences are based on like virtual reality and augmented reality, the different drying and flying simulators, the advanced object, the computer technology, the streaming technology, the overall experience itself, the security technology like NFTs and blockchain, and basically ways you can connect with the globe or sort of like other part of the universe. So it gives an experience of connecting the data across the universe in set of the time frame, in set of like the scope of the work. In my presentation, I'm also going to touch upon the points today that how players will interact, upload the different final video streaming platform. And after my presentation, Lupal is going to show you the video of one of the experience of a virtual game using the Metaverse platform. So as we talked about, like the day of the gamer, the person chooses a game and they start streaming the gameplay. Behind the scene, the technology needs to basically render all the objects that are out there into the game. The streaming technology also needs compression algorithms, a lot of data optimizations over there. Interactions and collaboration with the other player needs a constant high-end GPU services, which can not only collaborate on a high network bandwidth, but also have an intense compute power to make a decision based on person's thinking and mindset. We are also looking at some of the advanced level chip that are coming from Cycron and Tesla's owner, which are going to also make an impact in the way the metaverse is there. Because we are looking at a parallel universe where people can think and experience something that has not been done before. This is the platform that I'm talking about. In our Centaurus, we have, as Deepak has mentioned in the last conversation, that we got Arktos, which is a computer cluster management system, which allows you to basically spin more than 50,000 of the cluster parallelly, which can be in different regions and other things. Mizar provides the high-scale, high-performance cloud network system, which is also essential backbone of any gaming industry. We do also have an edge computing, which is like an edge site for the Metaverse services that's done through the Fornax. And all the AI which is required for basically making decision-making in the gaming is done through the Alnair ecosystem. You can see the hierarchy from the player to their avatars on the virtual world, where they are simulating their presence, their mindset, their experiences. The whole data has been captured or running on the compute environment, which is using the Alnair and Arktos, where compute and AI work hand in hand together in various regions. We can see the layer of Mizar, which is a network layer in between. And that's a total recipe for a powerful gaming solution that you would like to experience. All this technology has been developed as an open source platform in coordination with various companies like FutureWay, Click2Cloud, and several other players. And this is readily available for the gaming enthusiasts to basically explore and actually develop their own platforms for the future need. As I mentioned that you have coverage from storage, identity management, monitoring, security, and distributed architecture using these things. And as a part of Alnair, we are continue to work on event mining, the knowledge graph, and also the decision-making trees for various algorithms. So I would recommend you to basically join the community, use this infrastructure, and have a wonderful experience as a gamer. My colleague Rupal will take it over from here. Thank you very much for attending this session, and all the best for the happy gaming.
Hi everyone, my name is Rupal. I have been contributing into Centaurus as an outreach lead. It has been a great journey working on Centaurus to lead the next generation distributed cloud platform for 5G, Edge, AI, and Metaverse. So as Annie rightly mentioned about how the industry is evolving and how we are contributing towards the next generation cloud platform, whereas Deepak talked about a very detailed architecture and underline behind the technical side of the world. Prashant spoke about the business aspect. So let's deep dive about the future, that how it's evolving. We have been talking a lot and hearing a lot on the Dataverse side. So also the Metaverse. So as we have gone through the different industry trend, we know that the innovation is happening and industry is actually moving towards Metaverse, blockchain, 5G network, the expansion on the virtual reality, the artificial intelligence, augmented reality, virtual reality, cross-platform gamings, all those key pieces, which is really increasing demand of the different industry every single day. And when we talk about the gaming, it is really going to the very next direction, especially after pandemic. So let's see that how the gaming is actually playing the way that we expect it to happen in next 2-3 years. So from like 3D experience like AR, VR, to what eventually become a metaverse, the people all over the world want to play an increasingly metaverse game as seamless and easy as possible. While it will take a massive efforts across the industry to bring the metaverse to realization, but we believe creating this infrastructure and solving the challenges of cloud gaming are the point for us towards the solution and meet the game of metaverse on Centaurus. Isn't it amazing? Yes, it is. So the goal behind that is, if you see this all like magic behind the metaverse and dataverse is like distributed infrastructure, the network side low latency, while the videos or gaming is happening, or the edge computing to perform the different virtualization, the storage for video and audio streaming, whereas also the security for keeping the cloud game secures. So when we deep dive into all those key aspects, we know that like while we're talking about especially the infrastructure, so enabling the cloud game at the edge means developing a new hardware software infrastructure to address the challenges inherits a cloud gaming. So to make it happen, the Centaurus distributed cloud platform is all about the backbone behind it. So cloud-based gaming needs low end-to-end latency to provide fast and smooth gameplay experience, where quality of the video and audio have to be streamed at the same time without any jitters possible. So the infrastructure also needs to be capable for running the multiple games on a single cloud. The gaming servers to be economically efficient as well. So how this all can happen? When we are talking about the edge, it is really extremely important. Like the best way for a cloud gaming infrastructure is to provide a great latency for the players to bring it close to them as much as possible. So the data center alone cannot provide the level of ultra low latency, or we required a cloud gaming. So we try to focus on how we can solve that challenges in Centaurus through distributed edge computing, where we bring the cloud game infrastructure closer to the players by developing an edge, what we call it like metropolitan areas were close to the large populations. So to run themselves to run this kind of infrastructure, you of course need a storage where your video and audio is streaming. So ultimately, that delivering the smooth video and audio is also one of the most important part of the cloud game experience. So anyone who has played an online game is familiar with the frustration that they can see because of the latency that can cause. So let's start to think about the basic streaming flow that can solve through this infrastructure. Then the next is about the network side. So having edge computing side close to the players also like help to reduce the video and audio latency through the streaming pipeline to GPUs. That can also be one of the core piece by using the Centaurus towards Metaverse. The security, of course, as I mentioned, the keeping cloud games secure, like players and developers need to be assured that any cloud game experience is secured and safe. So player need to know their data is safe and game that won't like dominated by creators, or the developer need to be assured their product will be like safe from privacy and other security vulnerabilities. So where the data is flowing, how it's flowing, it's all around the edge AI and different key aspects that we have designed behind the scene of this Centaurus. Of course, there has been a lot the future is happening. So we talk about edge, orchestrated platform, multi-cloud tenant, the networking, high performance. Now the next what we are working is more regionless computing platform. So the enhanced version of distributed cloud, where new application model, APIs, global resource management, all can work hand to hand. As I mentioned, it's an open source project. It is been announced under a Linux Foundation umbrella back in 2020. So it's almost 2 years project now, and we have been contributing a lot. We have a great TSC members, the supporters, the contributors, the developers to enhance this project and reach to the actual industry needs. We are continuously like monitoring and understanding the market trends and how we can help to solve those needs. So this is all about our PR and releases that we had around Centaurus. You can see we normally have the yearly meetup and the summit as well. So our upcoming summit is going to be in December this year. Last year we had a very great success. Back to back 2 years we had a very great success for Centaurus, where about 1,000 plus people have joined, and we are really like motivated to lead it to the next level. While we are talking about this as an open source project, so we have our special interest groups as well for sustainability, for scalability, for networking, for edge and AI. So basically all those groups has a very focused area. So feel free to join this group. It's totally open source. We have our like open source code, which is available on https://github.com/Centaurus-infra. You can find all the different projects under that repository. We have our mailing groups, Slack, and the different weekly meetings, monthly meetings. So feel free to join that meeting and please participate in this project to grow the ecosystem. This is all about us, and in case you have any question, any ask, please drop us email or join us on Slack. Thank you again for listening, and it has been a great journey working with Centaurus, and we really look forward to seeing you all joining and being part of the Centaurus family. Thank you.